6-4 number 40, find the derivative. Our function is y is equal to 2x plus 5 to the third power times the square root of 4x minus 1. You do not have to do logarithmic differentiation for this problem. If you don't do logarithmic differentiation, you would find the derivative by using the product rule. However, it may be easier to use logarithmic differentiation, and in fact the instructions are asking us to do that. So we'll go ahead and find the derivative by using logarithmic differentiation. As I said earlier, you could just use the product rule, but it might be a lot of algebra. So let's see how to do this by using logarithmic differentiation. So you would begin by taking the natural log of both sides of the equation. Before we go any further, we can simplify or expand the right side of this equation by using the product property of logarithms. So here we have the product property of logarithms, and using that, I can rewrite the right side of the equation as follows. So here's one factor and here's another factor. So I can write, using the product property of logarithms, the natural log of 2x plus 5 to the third plus the natural log of the square root of 4x minus 1. Now, you can rewrite square root as raising to the 1/2 power. So I'll do that, setting up for the next step, which is to further simplify each of these logarithmic expressions by using something called the power property of logarithms. If I have the natural log of a to the n, you can write that as n times the natural log of a. So we're going to do that by taking this exponent of 3 and writing it out front, taking this exponent of 1/2 and writing it out front. So that will give us the natural log of y is equal to 3 times the natural log of 2x plus 5 plus 1/2 times the natural log of 4x minus 1. And now that we've done that, we're going to differentiate both sides of this equation with respect to x. So on the left side, to find the derivative of natural log of y with respect to x, you would use implicit differentiation. Y is your inside function, and you have natural log of y. So using the chain rule, the derivative of natural log is 1 over the argument, and then I have the derivative of y with respect to x, which is what I'm looking for. It's the derivative that I'm looking for, dy dx. And on the right side of the equation, I'm going to have to differentiate term by term because I have a sum of two terms. And for the first term, I have a constant multiple of 3. So I would have 3 times the derivative of natural log of 2x plus 5. The derivative of natural log of 2x plus 5 is 1 over the argument, 2x plus 5. And then you would use the chain rule because this is your inside function, so multiply by the derivative of the inside function, 2x plus 5, the derivative of that is 2. And then you go to the next term, so there's the plus sign. The next term also has a constant factor of 1/2, so I would write that here, 1/2 times the derivative of natural log of 4x minus 1. Again, natural log of 4x minus 1 is a composition of two functions. The inside function is 4x minus 1. So the derivative of natural log is 1 over the argument. So I have 1 over 4x minus 1. And then I would multiply by the derivative of the inside function. The derivative of 4x minus 1 with respect to x is 4. So there's my answer. I can clean it up a little bit. So this is the last line from the previous slide. So now we'll go ahead and clean up the right side. And what we can do is we can just go ahead and multiply 3 times 2. That'll give us 6 in the numerator over 2x plus 5. And then here, when you multiply 1/2 times 4, half of 4 is 2. So that'll leave us with 2 in the numerator over 4x minus 1. And again, in this problem, what do we want? We want the derivatives. We need to isolate dy dx. And the way we do that is by multiplying both sides of the equation by y. Because when I multiply the left side of the equation by y times 1 over y is 1, leaving me with dy dx. But what I do to one side, I must do to the other side. So I multiply the right side of the equation by y as well. And finally, I can conclude my problem by remembering what y is in this problem. What is y in this problem? Y is equal to 2x plus 5 to the third times the square root of 4x minus 1. So now I will go ahead and replace y with what y is. And there's my final answer. And you can leave it like that. That's good enough.